Hello students, today we will see the resistance connected in series parallel configuration. So resistance connected in series and resistance connected in parallel configuration. So in this video, firstly we will start that the two resistance are connected in series, that is R1 and R2. So when the two resistance are connected in series, the resultant is R1 plus R2. Similarly, we will see if the resistance are connected in parallel. So I will draw the two resistance R1 and R2 that should be connected in parallel. So here in series that two resistance equivalent resistance R that is equal to R1 plus R2. In parallel, we will draw one equivalent circuit. So R1 and R2 must be converted in R. So R equal to R1 in R1 parallel with R2, that is R1 into R2 divided by R1 plus R2. So these are the series and parallel configuration of resistance. So afterwards we will see some problems that should be related to resistance are connected in series, and afterwards we will see resistance are connected in parallel, and after this we will see if both the resistance are connected in series and parallel configuration. So here resistance are connected in series configuration. So here that two resistance are connected in series, that is 5 ohm and 6 ohm. So the resultant is the addition of two resistance are equal to the 5 ohm plus 6 ohm, that is the total is 11 ohm. Similarly, we will see another problem. So in this problem, if two same value of resistance are connected in series, so resultant is addition of these two, that is 12 ohm, that is double of a previous one. So here 6 ohm plus 6 ohm, that is R equal to 12 ohms. Then afterwards we will see one more problem. So here four resistance are connected in series, that is 6 ohm, 3 ohms, 10 ohms and 10 ohms. So all these are connected in series. So resistance will be looking from the left hand side. So R equal to 6 ohm plus 3 ohm plus 10 ohms plus 10 ohms plus 10 ohms. So the total is 6 plus 3 plus 10 plus 10, that is a 29 ohms. So R, make a bracket. So this is your answers. Afterwards we will see the resistance are connected in parallel configurations. Resistance are connected in parallel configurations. So if two resistance R1 and R2 are connected in parallel, so resultant is R1 into R2 divided by R1 plus R2. So here again I will draw the two resistance, that is R1, R2. So the resultant is single resistance R, that is equal to R1 into R2 divided by R1 plus R2. Similarly, we will see one problem on this one. So here two value of resistance we have connected in series. So here 5 ohm and 5 ohm. So remember, if two equal value of resistance connected in parallel, so resultant will be exactly half of single ones. So here R equal to 5 into 5 divided by 5 plus 5. So 25 divided by 10 is 2.5 ohms. So R equal to 2.5. It is equivalent to half of the single resistance. Then next we will see one more examples of resistance connected in parallel configurations. So here again two resistance are connected in parallel configurations, that is 2 ohm and 3 ohms. So R equal to the resultant is R equal to 2 into 3 divided by 2 plus 3. The resultant is 6 by 5, that is 1.22 ohms. So here this is the final answer, R equal to 1.22 ohms. After completion of this, we will see the combination of the series and parallel configurations. So if resistance are connected in series and parallel, what will be the conditions? If resistance are connected in series and parallels, so here, so from this side, that is from the left hand side, we will find out the value of equivalent resistance. So here the 4 resistance are there. From this side, left hand side, we will find out the value of resistance. So here this is a 3 ohm, this is 2 ohm, 1 ohm, and this is 3 ohms. So always remember, we have to find out the value of or solve the problem from the right hand side. So from right hand side, we will see 2 ohm and 1 ohm connected in series configurations. So firstly we will solve this. So 3 ohm and 3 ohm, again we will draw one equivalent resistance, that is 2 ohm, that is 2 ohm plus 1 ohm, 2 plus 1, that is 3 ohms. So this 3 ohm and this 3 ohm are in parallel. So already I will explain that two same value of resistance connected in parallel, so equivalent will be exactly half. So the value will be 3 ohm parallel with 3 ohm, that is value will be 1.5 ohm. So 3 ohm in parallel with 1.5 ohms. So these are in series. So here the 3 ohm plus 1.5 ohm, that should be the equivalent value, that is 3 ohm plus 1.5 ohm, that is 4.5 ohm. So R equal to 4.5 ohms. This is the final answer. So in this video we will see the resistance are connected in series and resistance are connected in parallel. Also we will see the parallel and series configuration of resistance. Thank you.